Good morning. This is Dr. Sarita Prashant Patil from Sanjay Godhavati University, Kolhapur. Let us start with the electrostatics. So, electrostatics is nothing but the electric field which is produced by static charges. Very simple. Here we look at two charges. One is a positive charge and second is a negative charge. How to recognize an electric field? So, let us consider a positive charge. It will has it will have its own electric field in its region. For example, let us consider up to the distance r, it has its own electric field. So as we move away from this charge, that is, as this r distance increases, electric field decreases. And this particular can be considered, this particular can be understood with the help of a Coulomb's law. Coulomb's law states that this electric force is inversely proportional to r square. Similarly, electric field also is inversely proportional to the distance. So, as we move away from the charge, electric field will decrease. So, this is what is called as a static charge, and this is how electric field is produced by a static charge. Now, how electric field is recognized? Electric field can be considered with the help of electric field lines emitted out by a charge. Actually, electric field is represented by an electric field lines. So, let us consider that the electric charge that is having a positive sign is concentrated at the center of a sphere. Now, we are going to understand with the help of these two diagrams a Gauss law. Gauss law states that the divergence of electric field. So del dot, it means the divergence. Del is the operator which operates on a vector. Here electric field act like a vector field. So del dot is nothing but a divergence. So divergence of an electric field over the volume V is equivalent to the surface charge density enclosed by surface of a sphere. So let us see how logically it can be understood. So this positive charge is concentrated at the center of sphere. It emits out electric field which is shown in the form of electric field lines. So whatever amount of electric field lines or whatever number of electric field lines are emitted out by this charge in this sphere are considered inside the volume. So whenever charge emits electric field lines, then those electric field lines will be emitted out through the volume. So charge emits out electric field lines throughout the volume of a sphere. Similarly, if we move from this center of the sphere to the surface of sphere, then whatever number of electric field lines are emitted out by this particular charge, all these lines will reach after some time to the surface of sphere, and all those lines will be observed, same number of lines will be observed on the surface of sphere. So here if we consider, for example, 4 plus 4, 8 lines are emerged out from the volume of this particular sphere. Same 8 lines will be observed on the surface of sphere. So what is written here? Electric field lines coming out through the surface of a sphere. So these are the electric field lines coming out through the surface of sphere. It means that whatever number of lines are present inside the volume of a sphere is equivalent to whatever number of lines are observed on the surface of sphere. It clearly indicates that the amount of electric field present inside the volume of a sphere is equivalent to the charge density present inside the sphere. In a very simple form, Gauss law is written by this expression: del dot E is equal to rho divided by epsilon 0. Now here in this particular, with the help of this particular pictures, we are going to understand two things. One is a divergence of electric field and second is the curl of electric field. So this is how divergence and curl of electric field can be understood with the help of this particular diagram. So what do you mean by divergence? Divergence means these lines are moving away from the positive charge or they are moving towards the negative charge. However, in both the pictures, if you see these two lines, they never intersect each other. So they will move away from each other. So they will not come back and they will form a loop with the earlier line. So this particular line which is emerging out from a positive charge, it will never form a loop. Similarly, the line which is reaching a negative charge, it will never form a loop here. Okay, so it has a diverging nature, and therefore divergence of electric field, it has a certain value, and that value is represented as rho divided by epsilon 0 in the form of a Gauss law. However, now if you look at the del cross, so here this sign indicates a cross product. Del is an operator. It operates on electric field E. So del cross is nothing but a curl. It forms a curl. Like del dot forms a divergence, here del cross forms a curl. And therefore, when curl is operated on this particular electric field, it comes out to be 0. Why? Because curl logically means that formation of a loop. So if in electric field vector it forms a loop which is not shown, which is not observed in the case of these two charges, then del cross E is equal to 0. So how these charges are, what is the nature of these charges? Nature is static. These two charges are static charges. So from this particular expression it is seen that for static charges, since electric field lines they do not form a loop, del cross E is equal to 0. So this is how to write a divergence and a curl of electric field in electrostatics. Thank you for today. See you later.